Okay, now we're going to talk about oxidation reduction reactions. Oxidation is a cause, for example, of rusting of metal. Oxidol is based upon oxidation, helps clean clothes. We have many oxidation reduction reactions going on in the body. Sometimes these can go astray, and that's what the basis of free radicals are. Oxidation, basically, we will say, is to remove electrons, to oxidize something, to remove electrons, as you can see as you read it. Reduction is basically to add electrons. So oxidation, let's say, is to remove electrons. Reduction is to add electrons in a reaction. Okay. The reactions are coupled. For example, let's say the sodium chloride issue. Sodium, if you recall, was less electronegative than chloride. Chloride, therefore, pulled the electrons from sodium. Since sodium lost the electrons, it became oxidized. Since chlorine became chloride and took the electrons, it became reduced. So oxidation reduction reactions are coupled. We often, in chemistry, they call them redox reagents. Because sodium caused chloride to be reduced, it's called the reducing agent. See, sodium lost electrons, causing chloride to be reduced. It's the reducing agent. And because chloride caused sodium to be oxidized, the chlorine is the oxidizing agent. So glance at this here, and you can kind of see how these actions, because the electrons have to go someplace, shall we say. There has to be an exchange, right? If the molecules are ionically bonded, like sodium chloride, there's a complete change in the electrons. But however, if it's polar covalent, one side does slightly lose the electrons and the other side gives them up. So in that particular case, there is a slight oxidation reduction reaction, even though there was not a complete removal. Okay? A free radical. A free radical is basically a highly electronegative atom with an unpaired electron pair. And basically what it does is, as you recall, atoms like to fill their outer shell. So if an atom is highly electronegative and doesn't have its electron pair filled, it will go out and scavenge to take electrons from anywhere. Those electrons may be vitally needed by another reaction, but they don't care. Now, when you take the electrons from that reaction gets upset, and if it's highly electronegative than one close by, it'll steal from that. So what happens is it forms a chain reaction, these free radicals. Okay? Now, because you are stealing electrons, then things are getting oxidized. So we would call these an oxidant, getting oxidized. So in order to alleviate this or stop this action, we need what we call antioxidants. Antioxidants. Now, in our human body, as I alluded to, there are many free radical reactions going on. Free radicals we know now are responsible for some aspects of cancer, for some aspects of aging, from some aspects of inflammation. A lot of work done on this. Since our body naturally produces some free radicals, as a matter of fact, the oxygen we breathe, most of it goes to do what we need to do, producing energy, but about 2% goes as free radicals. So we have many reactions in the body that will produce free radicals. That's natural. But in our body, we have natural antioxidants. However, sometimes they are not enough based upon the environment, the foods we eat. So that's where we have to sometimes take antioxidants in from the nutritional sources and so forth. All right. So how does an antioxidant work? Primarily, what it does is it will hand the electrons to a free radical and make it satisfied. And what hands it to the free radical is not affected whether it had the electron or not. So that in a sense ends it. Enzymes that do this action that our body has, a superoxide dismutase, glutathione peroxidase. Not that you have to memorize these, I'm just showing you how it works there. Oxidation in our body creates energy. Remember, energy is the capability to do work. Work is force times distance, so you have to move something. Because oxygen, nitrogen, phosphorus can move electrons, then in a way you're liberating energy. That's the basis of, because when we breathe oxygen, our oxygen is to help produce energy in our body by oxidizing the food we eat, as we'll look at it in particular in ANP2. So it's an oxidation process that allows us to create this energy to make something we'll later talk about called ATP, which is our body battery. So again, oxidation, removal of electrons. Sometimes hydrogens come with it too. Reduction, adding electrons. One way of thinking about it is, if you take electrons, you increase the positivity. And if you give electrons, you decrease, you make it more negative, reduction. As we alluded to, these reactions are very vital in our body for many reasons. Oxidation helps with metabolism. But it can go haywire, in which case free radicals are formed that we have to eliminate. Now, one note we'll make when you get into ANP2, sometimes you can make a bad thing good. So some of our white blood cells, our neutrophils and macrophages, have enzymes that produce free radicals. But these free radicals are used to kill bacteria they engulf and other organisms. So there are some good uses in the body for free radicals, and I did want to point that out. All right, please study on this, and we'll close here on this issue.